so we're going to carry on from what Hannah talked about last time with regards to Ohm's law, and we're going to ask a question around how much power is put out in a particular circuit. So Hannah gave you Ohm's law last time. Remember Ohm's law, V equals IR. So it related the voltage or potential difference with the current and the resistance. And what you actually want to know is how much energy is involved. I mean, if you're going to put a light bulb, how much energy is going to come out of your light bulb? If it's rated as 100 watts, what does that actually mean in terms of electrical current and resistance and voltage and those sort of things? So the formula for power, P equals VI, is the basic power formula. So let's just have a go at doing something. So say we had a 12 volt supply hooked up to a resistor of 100 ohms, and the question is going to be what power output is this setup going to have? So let's have a look at asking two questions. What power is output, and how much energy per hour? Okay, so just set up this, we've hooked up a 100 ohm resistor inside a 12 volt power supply, and we want to know what is the power output. Rightio, well, my formula for power is that power is voltage times current. Well, I know what the voltage is, so I'm going to have to work out the current to drive that formula. Thankfully, I've got the V equals IR one, so I can rearrange that. I is V over R, is 12 volts over 100 ohms, is 0.12 amps. So in the circuit, I've got 0.12 amps. Yep, and that enables me to work out the power. So power is VI, voltage is 12 volts, current is 0.12 amps, which is 1.44 watts. Okay, so that circuit is going to deliver 1.44 watts is the amount of power which is coming across this system out of that circuit. And then we can figure out how much is happening in an hour just by using a normal formula that tells us that power is energy over time. We're rearranging that. Energy is power times time is 1.44 watts times the time, 1 hour, 3,600 seconds. So grab the old calculator, turn it on. We've got 1.44 times 3600 equals 5.2 kilojoules. Yep, so in this particular circuit, there's going to be 5.2 kilojoules available from here every hour. And if you don't have some way of taking that away, this thing is going to heat up. So that's what happens with resistors. When you run a current through them, they turn that energy into heat. And unless you've got some way of taking that heat away, your circuit is going to overheat and you're going to potentially have some trouble at this point. But the idea here, the key idea here, is power is exactly the same as power we've dealt with previously when we did like stuff on kinetic energy and potential energy and work and power. It's the same thing. So it's just measured in watts. It's just joules per second. But now we have a formula that enables us to work out electrical power. So when we know what's going on in an electrical circuit, we can still work out the power involved in that. Okay, so P equals VI is the essence of it.